Alright, in this video we're going to talk about Unit 7, Objective 2, the accumulation functions. We talked about this a little bit when we did Riemann sums and trapezoidal rules. The big idea that we need to get out of this objective is that an integral will tell you the total change in the antiderivative. So the integral is the total change in the antiderivative. And that's what we need to kind of put into our brain when we're thinking about justifying, or if we're thinking about units, is the total change in the antiderivative of what you took the the integral of. This mostly shows up excuse me, when we are taking the integral of a rate. So mostly shows up taking the integral of a rate. And when that is the case, your new units are no longer a rate. So if you think about the antiderivative of a rate, you no longer have a rate. So the problem we're going to look at is a pretty quick one. It is from the worksheet that we did with Unit 7, Objective 1. With the swimming pool. I cut out part B from that worksheet, so now we're going to look at part B. So we have a swimming pool. The pool contains 1,000 cubic feet of water at time t equals 0. There's a leak. The water is leaking at the rate R, capital R of t equals 25 e to the negative 0.05 t. Part B wants us to calculate the total number of water that leaked out of the pool during the time 0 to 12 hours. So if we look at what we're given R of t is that, and R of t is the rate in cubic feet per hour. So if we're trying to find the amount of water, that would be cubic feet of water. So if I have cubic feet per hour and I want cubic feet, I need to integrate the rate at which we are losing water. So we want to integrate from 0 to 12, because that's the time interval they give us, of capital R of t dt. Now this was a calculator question, so you would just toss that into your calculator, and you'd get 225.594. Now, to talk about our units, again, we had cubic feet per hour. We took the integral, so we're going to just have feet, or cubic feet, left over. So tying this back to our total change in the antiderivative. The antiderivative of cubic feet per hour is cubic feet. So we have changed 225.954 cubic feet. That's the total change in the antiderivative. Now this question could say something like this, and they could ask for how much water is in the pool at t equals 12. And this is assuming that we aren't adding water like we are in this actual problem. But if we aren't adding water and we're just leaking water, how much water is in the pool at t equals 12? So we still want to think about our integral, because it wants how much water. Now, this is going to tell us the total change in the water. So it's the total change in the water. So we need to think about our initial value. How much water did we have at the beginning of our time interval? So if we look back up the top, we have 1,000 cubic feet. So that 225 is the answer to B, how much water has leaked out. But if they ask how much water is in the pool, we have to say our initial 1,000 cubic feet, and then we would take away how much we changed. So again, that 225.954 is going to be the total change in the antiderivative, the total change in the amount of water that we have. So if you were to do that, we'd get 774.406. Stylus disconnected. That's fun. There we go. So we would have 774.406 cubic feet. So the biggest problem with these is being able to figure out, do you want to use your initial value or not? So you have to look closely at what the question is asking. Other than that, it's just taking an integral. We have to know that integral means the total change in the antiderivative. So that'll do it for this video. See you in the next one.